Those lessons brought to you by, I believe this is one of the Monster Fighter Lego minifigures. I didn't bother to look them up. So, Unit 1 is all about numeracy. So, uh, having an understanding of numbers and just kind of what to deal with them. And really, the major theme of Unit 1 is what's up with percents. So, Lesson 1.1, we start with these four objectives. Can we perform conversions and calculations involving percents? Can we find this idea of a percent increase or decrease? And then can you solve some problems using percents and just understand the legitimacy of claims based on percents? So I think the first thing we really want to understand is when we say percent, what does that mean? What is the definition of percent? If you read here this first paragraph under the class section, you'll find our author's definition of percent as being literally per 100, or that 1% equals 1 divided by 100. I like to think of this definition of percent as a part to a whole, or a part of 100. So percent means part of 100, which is what this is saying here. If we write the word 100%, that means we have one part out of 100, whatever that 100 is. So on the next page, we've got a couple problems where we're going to be asked to define, or using this means per 100, to convert percents into numbers. And you'll find that percents are kind of like a symbolic notation, and that in order to use them in calculations, we need them in either decimal form or fractional form. So here, number one, we're told to write 84% as a fraction and then a decimal. Well, if we use this definition, part of 100, the number represents the part. So that is 84, and then per 100, or divided by 100, which is what per means, we would literally write 84 divided by 100. That is the fraction. If we want to change that into a decimal, we can go into old school work. You may have done this back in elementary school. You may remember long division, and we're like, okay, how many times does 100 go into 84? Well, it's 0 times, right? So we have to add a decimal point and put a 0 here, and then say, how many times does 100 go into 84? So 100 times what equals 840 is what I mean there. And if I multiply by 8, I would get 800. If I did 9, I would get 900, so no good there. So we get 800, and then we would subtract this. So this, of course, is 0, and then 4 minus 0 is 4, and 0 minus 0 is 0. 100 does not go into 40, so we need to include another 0 now, and blah, 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 blah. Here we go. This is overkill, right? We wouldn't need to do this at all. In fact, we're going to use our calculators to do this. And actually, we're not going to do that at all, because do you notice what happened here? This 84 divided by 100 becomes 0.84, or you can just write 0.84. In other words, when you divide by 100, you move the decimal place, wherever it is, left 2 places. And that's your general rule that is always true. So now we can go much faster with this 9%. 9% as a fraction is 9 over 100, which then is move the decimal 1, 2 places. If there's not numbers there, include a 0.09 as a decimal. Awesome, not too bad, right? So then we get to some crazier stuff. Now here we're wanting to convert each percent to a fraction in lowest terms. Well, that starting part is quite straightforward. If we want to convert that 42% into a fraction, we do 42 divided by 100. Now, what we mean by lowest terms is that there's no number in common between the top and the bottom. So we could do this very slowly. We could think, oh, 42 is divisible by 2, and so is 100. So if I divide by 100 by 2, I get 50. If I divided 42 by 2, I get 21. And then we could ask ourselves, well, are there other numbers? Now that I have this 21 over 50, is there a number that divides into both of those? Well, you can think about the factors of 21 as being 3 times 7, and 50 is like 2 times 25, and 25 is 5 times 5. So we could write this. This is kind of a very, this might be too high level. I don't know. This might be confusing. You all let me know if this was confusing. Oh, don't write a 2 there. Times 5 times 5. So we could say this is 3 times 7 times 2 times 5 times 5 is what these numbers are. And there's nothing in common between the top and bottom. In other words, nothing we can divide out. So our final answer is 21 over 50. That is a fraction in lowest terms. Now, notice, if we wanted to write this thing as a decimal, I would just drop this down and say that this is 0.42 as a decimal, which means if we were to type this in a calculator or write it out in this manner, we would end up with 0.42 as the decimal version of that fraction. All right, we got one more. Now this one is wonky. I don't like this one. Honestly, I'm a big fan of technology. We have technology for a reason. Computer programmers and the like put this stuff together for us. So working with this 37.5%, yeah, I'm going to do it by hand, and then we'll talk about using decimals to do this. So remember that what this percent symbol means is divide by 100. That's precisely what that symbol is representing. So how do we deal with this? Well, if you look at what he says, after initially writing as a fraction, multiply by 2 over 2 so the numerator and denominator of your fraction are both whole numbers. What? Well, this is what he's saying. You do 37 and 1/2 divided by 100. And then we're supposed to multiply the top and bottom by 2 over 2, which is a little strange. So let's talk about what's going on with this 37 and 1/2. So this 37 1/2 means, as a decimal, it really means 37 times, well, oh boy. So it really means, and the way this notation is, because a mixed number, it really means 37 plus 1/2. If you think about 1/2 as a decimal, that is 0.5. So we could also write this thing as 37.5 if we so chose. So if we want to get this into what was often called an improper fraction, we would need a common denominator, which is where that multiplying by 2 over 2 comes in. So I would multiply this 37 by 2 over 2, and what is that? 64 over 2, 74 over 2, easy killer. 74 over 2 plus 1/2, which would end up getting us 75 over 1/2. That is what this number is as an improper fraction. So if I come back over here, and I think this is getting a little messy, I'm going to rewrite this 37 and 1/2 divided by 100 as what I just turned it into. 75 over 2 divided by 100. So I'm not really following what he said to do in order to get the whole numbers. What I'm going to do is show you another option, and that is when we divide fractions, two fractions, we can write the notation this way using the division symbol. And what happens is you multiply by the reciprocal of the divisor, the number you're dividing by. So this becomes 75 over 2 times 1 over 100. Well, and then if you remember how to multiply fractions, you just do top times top, bottom times bottom. This ends up 75 over 200. Now we have a problem here. Well, not really a problem. We don't have this in lowest terms because I know that the top and bottom are both divisible by 5. So let's do that. Divide this by 5 and divide this by 5. And let's see. Oh boy, 75 divided by 5 is 15, am I right? 5 goes into 7 once with the 25 remaining. 5 goes into 25 5 times. Yep. And let's see, 5 goes into 200, so 5 goes into 24 times, remainder of 0, so 40. So 1540. Oops. We still have a number in common. One of those tricks is if the last digit of the number is divisible by 5, then the entire number is divisible by 5. So I'm going to divide both the top and bottom again by 5, and I get 3/8. That is our final answer. In the next video, I'm going to show you how to do this in Desmos.